I think, well, maybe you don't know how this process works, right? We've got about 15 minutes, and I'm not expecting you to present anything. It's really, I want to take opportunity to kind of ask you a few questions that maybe need a little bit more elaboration in your report. So that's what this is all about. If we have a little bit extra time at the end, I'm sure I can answer any questions you might have too as well. First, I guess I hope you're enjoying yourself at the conference despite all the logistics kind of challenges we've been having. So let's see. I guess one of the key questions I have is how did you land on selecting an M795 motor for your rocket? What was your thinking process for that? I note that you don't meet kind of the rail exit velocity requirements, right? So, when I think about like, how did you land on that particular motor? What other motors did you select or evaluate? What was that process like?
I can start with that. And hi, of course, my name is Alan George. I'm the structures lead for FIU. I'll start with that question, and hopefully, ladies, she's a recovery lead, can go into our other motor options we had. So our due to COVID-19, our construction process started a lot later. So we started back in October, and we initially had that motor, the that M motor that we chose, and it did meet those requirements, like of the thrust ratio and the over the 100 feet per second requirements. But after construction, the original design of our rocket stated that we estimated the constructed weight fully loaded to be around 55 pounds. But after construction, it ended up being close to 63 to 64. So an added almost 10 pounds really changed a lot of our simulation data, and a lot of that stuff had to be adjusted actually after like close to the technical report and presentation. So that's just the data that we had at the time to present. Ladies, do you want to mention the other motor that we have? Just the quick descriptions of it.
Yeah, the other option that we were looking into was the M3400. I'm sorry, give me 1 second. I'm nervous.
Yeah, the M3400 is kicking the pants. That's a significantly bigger motor, right? Almost 5 times bigger, right?
Yeah. So we decided to go with that was our second option, but that wasn't optimal in our situation because we actually chose the first motor due to its long burn time, because the Mach number was around 0.65, and our fin flutter calculations, the material we used was structural fiberglass, and like it was just ease of manufacturing. And the fin flutter calculations we used gave us a Mach fin flutter divergence of 1.04. And if we use that high impulse motor that ladies just mentioned, it would put us very close to that fin divergence number. So initially, to mitigate that, we did do a fiberglass tip layup, but just to be on the safe side, we went with the initial motor, the long burning one.
Right, I understand the fin flutter concerns, and but most people when they're I don't know what kind of fin flutter calculation you did off the top. I've been looking at so much stuff lately, I don't remember those details in your final report. But there's always there's a big fudge factor in there that's related to manufacturing effectiveness, and you're a fairly novice team. I don't know how many high impulse motors that you've put or rockets you've put together, and your expertise with tip-to-tip layup, and or even how do you make a good fillet in your design. So I understand the natural aspects of being conservative. I'm also concerned though that the rail exit velocity is below kind of that's really kind of a safety requirement, right? Because if it comes, it's really easy for it to come off slow and then kind of go sideways. It's maybe not all that dramatic, but sometimes it means a long walk. And I note that it's going to be 111 degrees down in Spaceport America tomorrow, which would maybe in the middle of your launch, if you happen to be launching, a long, long walk at 111 degrees is something you'll remember for a long, long time. What kind of, what do you think, you know, coming into this as a novice team, what was some of the hardest or the biggest learning experiences that you had? Not the payload area, but more in the rocket design area. Any comments there?
Well, I can start off with that, and James, the project manager, can continue after me. So the biggest difficulties in the design phase, of course, was just team management and getting everyone together. All of us didn't really know each other until we came together for Spaceport America, and we met online. So the first time we met each other in person was actually for constructing a subscale. So being able to come together, and most of us being relatively amateur, we're very thankful for Chris. He's our safety mentor, and he's been an amazing help. So the most difficult part has been in the beginning, of course, was just coming together and just getting everyone to the same level.
You know, 1 second. Somebody needs to go on mute. That'd be you, Ben. We got a team presentation going on, so please put on yourself on mute if you're not talking. Okay, go ahead. Sorry, Alan.
All right. Yeah, that was just my point. James Lee, as the project manager, do you notice what was the most difficult part starting off?
I would say kind of, I can talk about from essentially the inception of it. So the team was originally, we were trying to compete in a competition about since 2018, but for that year, we weren't granted entry, and then we did gain entry to compete the following year. But at that time, that's when I got interested in competing as far as part of the team. But I would say the chief engineer at the time, as we got more closer to the actual competition, that's when COVID happened, and he kind of went MIA. So it's kind of more so of having somebody like myself who's very interested in rocketry and kind of learning a lot of things by yourself, which because there's a lot to learn when it comes to rocketry as far as, so it's kind of more so just learning the basics and also finding people who are actually like Alan said, kind of dedicated to be a part of the project, because a lot of times it's cool, once you start getting to manufacturing, that's when everybody wants to help out. But those late nights of doing research and actually working the project updates, completing the technical report, you don't get as much as people who are very hands-on with that. So that's as far as saying it would be one of the difficult things.
Yeah, I think it's always tough pulling together a brand new team, and then these are pretty significant objectives, throwing a big bird like this up in the sky.
Yeah.
I was reading your reports, at least your final report. There was a lot of information that you were missing in the report that is kind of the detailed kind of information that a level 3 TAP would be looking for to kind of be assured that all the I's are dotted and the T's are crossed. Things like, your rail buttons design. It's a silly little thing. And normally, if we were actually launching in person, we'd be doing a hang test on the launch rail. And if the buttons broke off, well, you'd be running back to your tent to figure out how to patch it. In the absence of that, right, it's almost like, how do you look at the design? There's some little details like that were kind of missing in your report. And then it's probably a little too late to have that conversation, but I would encourage you, first off, I'd love to see you guys fly. We're not gonna have a chance to do that this year unless you've got another flight location that you're planning on launching in. I'd love to see you guys, entering again next year and kind of, anteing up your build and bringing some more SRAD kind of components to bear. That kind of comes with the experience of building and flying your first couple of rockets. But I also, if you're entering, make sure you put those levels of detail in there, because it's the small things in rocketry that go wrong. It isn't necessarily the big things, although there can be big things that go wrong. It's the small ones that kind of take you completely by surprise. Right? Where do you, just along those lines, Are you planning on entering again next year?
Yes, we plan on entering for next year.
Have you got a similar kind of mission in mind, or have you got some other things that you want to be accomplishing next year, in comparison to the projects that you've done this year?
So this year was, of course, like a learning curve for all of us. So it'll be based off like common methods in model rocketry and amateur high power rocketry.
Right.
So for next year, like you mentioned, like trying to do a lot more SRAD components, even if it's not fully, like working with actual layup and composite manufacturing, not just the tip to tip. And we have some electrical engineers and computer science majors who are thinking about SRAD flight computers. And we can use that as like, for that primary, they can be backup for data collection for the future.
Yes. Well, good. I want to say congratulations for getting your entry in the first place and for following through, and particularly in a very difficult year. And I do actually look forward to seeing this thing fly one of these days. So, if you have a social channel that you're putting this stuff up on, I'll have to try to find it, and so I can keep my eye on what's going on. And we're unfortunately out of time and a bit squashed for time, and I apologize for some of the snafus here today. But good luck with the rest of the competition and have fun. Make sure you attend some of the sessions by some of the employers and other sponsors that are involved. There's a lot of people that are really interested in the work that all of you are doing. Okay.
Thank you.
Okay. Well, thank you very much, and have a pleasant rest of your summer. Okay.
Thank you.
You too.
Bob, thank you very much. I appreciate your time.
Great.
Yeah. Okay. Bye now.
Thank you.